Alright, and now we're looking at level 2 questions. We see some three-dimensional things. Makes things pretty interesting. The diagram shows a right pyramid on a horizontal rectangular base AB, CD. And given that AB, alright, 6 cm, BC, 8 cm, VA, 13 cm, find the length of AC. So, to do this, really, we have to look at it from the top of the pyramid, and what we will find is that that is D, A, B, C, 6 cm, 8 cm, and we're trying to find A, C. Right pyramid means all these are all right angles, right? So all these are right angles. It's a rectangular. It's a rectangle. How can we find it? Pythagoras theorem. We simply say AC squared equals to 6 squared plus 8 squared, which is 100. AC, therefore, is square root 110. Done. That's pretty easy. And now let's look at double I. Using this answer, 10 cm, can we find the height? Okay, so this is a bit more tricky. We know that this is now 10 cm. For the height, we basically have to look at this triangle. Now, since it's a right pyramid, it tells me that this distance is actually 5 cm, right? And this distance we already knew is 13 cm, right, from here. So really, the triangle we're looking at looks like this. 5 cm, 13 cm, and we're trying to find Vx. So we can say Vx squared plus 5 squared, Pythagoras theorem again, equals 13 squared. Vx squared is therefore 13 squared minus 5 squared, 144. Vx squared 144, which is 12 cm. That's it. So this height is actually 12 cm. Now, part triple I, we say find VCW, where W is the midpoint of Vx. So in the middle here, let's just say this is the midpoint. So here, this midpoint, since the whole thing is 12 cm, this must be 6 cm. And they're trying to find VCW. So let's call this point W. We're trying to find this angle. Can you see? And we can see very clearly it's not a right angle triangle, right? This is not right angle, this is not right angle, this is not right angle anymore. And we're looking at the blue triangle once again. Yeah. Okay, so maybe it's a bit messy, so I'm just going to draw it here now. It looks like that now. Where this is 6 cm, 13 cm, and we don't know what this is. Okay, let me try to make it look neater. Okay. Now let's see what we can find. And upon really studying it, it's pretty hard to find anything here, really. But this is a right angle triangle. So right angle triangles really allow us to see more. So I'm just going to draw this triangle separately once again. So we're also looking at, okay, so this was C, V, W. Now I'm going to draw the triangle below, which is C, W, and then below I drew in red. So I'm going to continue drawing in red, this X. Right, and this is 5 cm, and this is another 6 cm, right? Because this is 12, this is 6, this must be 6 as well. So this gives me a bit more information because I know this is 90 degrees, right, which is here. Then I can say that for this angle, which is like a tangent CWX, therefore it's opposite over adjacent. So I can find CWX, which is tangent inverse 5 over 6. Yep. Which is, I like to leave it like this, but if you don't like it, you can also just say 4SF at 39.81. So that tells me that this is 39.81 degrees. Right. Over here. 39.81. And then that helps me to find VWC, which is this angle. So I can say that VWC is simply 180 minus 39.81, which is 140.19. Okay, why did I go through all that effort? Because if I know that this is 140.19, I can now apply sine rule. And how do I do it? I'll just demonstrate. Over here, okay. Let me just draw the triangle here. No, actually it's here. Because this is the angle that I have just found, which is 140.19. Then I can easily say that sine 140.19 over 13 equals to sine of the angle that I need, VCW, over 6. Right? This angle with this side, this angle with this side. Then we can say that sine VCW, simply multiply 6 over, is 6 times this. And we can solve. So VCW, we get 17.19 degrees. So if I want 1 dp, 17.2 degrees.